We are on to Unit 5, which is all about rational numbers, which a rational number is just a fraction. We'll get to that later in the chapter. But for today, we're just going to talk about fractions and decimals and how to convert between decimals and fractions back and forth. So the first thing we need to know is what a terminating decimal is. A terminating decimal is just as it sounds. Terminating is a word that means ending or finished. So in division, if the remainder is 0 and the division ends, the quotient is called a terminating decimal. So what we do with that, my example up here is to write 7/8 as a decimal. To do that, remember that the top number is divided by the bottom number. So the top number goes in the box, the outside number. Now 8 can't go into 7, so what we do is we put a decimal point and we add a 0. Now we ask ourselves, how many times is 8 going to go into 70? So I bring this decimal straight up because that's going to be in our answer. 8 goes into 70 8 times. 8 times 8 is 64. When I subtract, I get 6. I'm going to add another 0 and bring it down. 8 goes into 60 7 times. 8 times 7 is 56. We subtract and we get 4. Add one more 0 and bring it down. 8 goes into 40 5 times. 5 times 8 is 40. I know you probably can't see this in the video anymore, but my remainder at the bottom is 0. So 7/8 as a decimal is equal to 0.875. So to do that, we're simply dividing the top number by the bottom number in long division. You just keep adding zeros until eventually you get to an ending decimal, and that top number is your decimal answer. So we add a decimal point and you keep adding zeros until we don't have any more left. So make sure you have both that definition and that example down. I'm going to go ahead and move on and do some things over in that other sideboard. I'll leave that up there for a little bit. But next what we want to talk about is a repeating decimal. So there's a terminating decimal and there's what we call a repeating decimal. A repeating decimal is a decimal with a repeating pattern of digits. So for example, it could be 7.878787, and then what we would do, instead of writing ... we put a little bar over the 8 and the 7, and that bar over the 8 and the 7 is going to indicate that those two numbers keep repeating again and again and again and again and again. And so that would be a repeating decimal. And so that using that bar is what we call bar notation. I'm not going to define that, but that is what that looks like. And so there are certain numbers that you can always kind of assume are going to give you repeating decimals. And I'll go over some of those here in a second. But first, let's just take an example and write another fraction as a decimal. And we're going to this time use 5/12. So write 5/12 as a decimal. So again, top number goes on the inside, bottom number goes on the outside. 12 can't go into 5, so I add my decimal and add a 0, but that decimal comes straight up to help me form my quotient. So 12 goes into 50 4 times. 4 times 12 is 48. Subtract and get 2, so I add another 0 and bring it down. 12 goes into 20 one time. 1 times 12 is 12. We subtract and we get 8. Put a 0, bring that down, we get 80. 12 goes into there, 6 times. 6 times 12 is 72. And then I get another 8. Well, if I get another 8, now notice, as we've done our division, now I'm getting 8, and if I bring a 0 down, I'm going to get 80, and it's going to be 6 again, and it's going to repeat. So the 0.41 doesn't repeat, but that 6 repeats, so my answer is 0.416 repeating. And that means that 6 is just going to, if I were to keep adding zeros, I'm going to keep getting 8s and 8s and 8s and go on and on and on. And so that's how, so sometimes you'll notice that, and if that happens, you're welcome to use bar notation and to indicate, and you should use bar notation to indicate that that is actually a repeating decimal. Apologize for using the bottom of the board there. I know it's probably a little difficult to see. But if you notice there, the 80, when I subtracted the 72, gave me an 8. If I would bring down another 0, it would give me another 80, and that would continue to repeat. Alright, so moving on, I do want to give you a brief summary of some fractions. So these are some fraction decimal equivalents that you should know and that you'll want to memorize. So fraction decimal equivalents. So some of the easier ones, 0.5 is equal to 1/2. We have 0.25 is equal to 1/4. 0.75 is equal to 3/4. There are some repeating ones that are decimals. So for instance, if I have 0.6 repeating, that's actually 2/3. 0.3 repeating is 1/3. Let's see, what are some other ones here? Some other simpler ones. We have 0.2 is 1/5. 0.4 is 2/5. 0.6 is 3/5. And 0.8 is 4/5. It's most of the important ones. Some other ones you may already know. 1/10. So 0.1 is equal to 1/10, and then 0.01 is equal to 1/100th. So there's a few other side ones. So those are some of the easy ones that you'll want to memorize and know pretty regularly, and you'll probably want to memorize here after a while. All right. So the last thing they're going to probably ask us to do here is to take some of these, and they're going to ask us to compare two numbers. So maybe something like compare the numbers using greater than, less than, or equal to. So we'll just do a couple of these. The first one being 1/4 and 0.2. In order for us to compare these, now they're giving us a fraction and a decimal. In order for us to compare these, we have to write them as the same form. So you either have to write the fraction as the decimal or the decimal as the fraction. So let's put the fraction as a decimal. So if we look over at our comparison, 1/4 is 0.25. So if I change this to read 0.25 compared to 0.2, which is bigger, this one has an additional digit. But I don't want to just stop here. I want to go back to my original and say that 1/4 is greater than 2/10. And part B, wouldn't be fun if we didn't have some negatives in there. So negative 5/8 and negative 6/9. So what do we want to do here? Probably the easiest way to go about this is to divide these out. So what you're going to want to do is go 5. Now don't let the negative signs throw you off. You can do this with just regular division and then put the negative signs in there later. So 8 goes into 50 6 times. Oops, I want to bring up the 0, just the decimal point. 6 times 8 is 48. Subtract, we get 2, add another 0. 8 goes into 20 2 times, so that's 16. Subtract, we get 4, 1 more 0, and that's going to go in there 5 times. So now I know that that's a negative 0.625. I know I'm going a little fast here, but you can rewatch and kind of pause and see what my work is. So now when I put, oops, I reversed these. It's my fault. 6 goes on the inside, 9 on the outside. So we put a decimal point. 9 goes into 60 6 times. 6 times 9 is 54. Subtract that and we get 6. Notice what's going to happen here, where now if I add a 0 I get 60 again. It's going to keep repeating that. So that's actually 0.6 repeating. So we're comparing a negative 0.625 and a negative 0.6 repeating. This one is ever so slightly smaller because it's more negative. So that means that this is going to be bigger than negative 0.6 repeating. So that's our lesson. I know there's kind of a lot there. Went through that in a short amount of time. But again, feel free to go back and rewatch it. Go back and make sure you have all of the examples in there so that you know you have all of the information before coming to class tomorrow, especially those equivalent fraction decimal comparisons.